Hello. The next question is explain how the student can use the apparatus to investigate how the resistance of the thermistor varies with temperature between 0 degrees and 100 degrees Celsius. Now, if you recall, this was the very last question that we treated. If you look at the previous slide, that is this diagram. How are we going to use this setup to answer the question? Now, the most important thing is, first of all, to get your table. If I was doing this, I will advise you strictly to make your table of results. So the first thing that you should be doing is you are going to be changing the temperature. Okay, so that will be in degrees Celsius. Okay, so you are going to be changing the temperature between 0 degrees and 100 degrees. So I would recommend that you have a gap of 10 degrees, 0, 10, 20, 30, and then you keep going until you reach 100 degrees Celsius. Start with the table. So the next thing is you want to take note of the amount of current as the temperature changes, and you want to take note of the amount of voltage as the temperature changes. Then you bring back your idea of Ohm's law, which says that V over I, and that will give you the resistance in ohms. Now, there could be two ways of doing this. You could fix the amount of voltage using your variable resistor, as you could see from the previous diagram. You could actually, if you remember our diagram that we drew before, that is our thermistor, that is our ammeter, that is our variable voltage, which are represented as a variable resistor or variable, because by the time you do that, you're actually having a variable voltage supply or anything at all that will change it. So you then have this, your voltmeter across the thermistor that way. So you could actually keep this fixed, okay? Say you keep this at 3 volts. So we're gonna have 3 volts all the way. Okay? You could do that, and you will then be measuring the current as it changes. So your first current will be I1, I2, I3, I4, all the way. So you are changing the temperature, and as a result of that, something is changing which is responsible for the change in current. Meanwhile, you have already fixed your ammeter, your voltage. So the next thing is you do the calculation. So you can then find R1, R2, R3, R4, up until R10. So the next thing is you want to find the effect of the temperature on the resistance. So you can then plot your graph of resistance in ohms against the temperature in degrees Celsius. Okay, and then you can see the trend, and you can then use the graph to explain what you think the effect should be. And that is how that is done. By the time you explain how all of this will be done, how you set your for instance, how do you intend to change this temperature? For instance, you can start from a boiling hot water of 100 degrees Celsius, and then you can let it cool down, and then you take the measurement every 10 degrees fall in temperature. Or you can, so that is cooling, or you can start with ice, okay, say at 0 degrees Celsius, and then heat it up, okay, and then take the readings every 10 degrees Celsius rise in temperature. Either of this method will still give you a similar result. So either this part or this part. Now, you explain how the temperature is changing, so that will be your independent variable. You are measuring the current, that is your semi-dependent variable. You kept the voltage the same, but your final dependent variable is resistance, which depends on voltage and current, which you can then use V divided by I to work it out. All of this will give you more than 5 points from where your 5 marks can be achieved. And that is how you do a question like this. Thank you for watching.